Hello everyone, I welcome you once again everyone to my digital platform. So let's start our today's discussion on basic logic gates. So we are going to study basic logic gates, but before that you need to understand what is logic gates. So in physics, whenever we are talking about this logic gates, a logic gates has one or more inputs, but only one output. So whenever we are talking about this logic gates, the logic indicates a decision making process. A decision making process. That means if some condition will be satisfied, then only there will be output, otherwise there will be no output. So this if you want to explain the operation of the logic gates, we need to use Boolean algebra. So operation of the logic gates can be explained by using Boolean algebra. So this is a new term. What is Boolean algebra? So all of you know, every digital electronics is based on this algebra. This algebra only has two digits. And what are those two digits? 0 or 1. It can only read these two digits, 0 or 1. What does this 0 indicates? The 0 indicates off and 1 indicates on. Or you can say this 0 indicates no, 1 indicates yes. Or you can say this 0 indicates it's an open circuit, 1 indicates it's a closed circuit. So whenever we are going to apply this Boolean algebra in the logic gates, we can explain how the current is going to pass in the circuit, or current is going to flow in the circuit. So let us start our today's discussion on the basic logic gates. So whenever we will talk about the basic logic gates, we have three basic logic gates. So basic logic gates are of three types. The first one is OR gate. The second one is AND gate. And the third one is your NOT gate. So let's start our today's discussion on the very simple gate, basic logic gate, that is your NOT gate. So this one is very simple. Why I am telling? Because it has only one input and one output. And it is otherwise known as, it is called inverse gate. So why is it called as inverse gate? If you draw the truth table for it, the truth table for NOT gate is, since it has only one input, so let us write it as the input to be A and the output Y. So it is inverse gate, and the Boolean symbol for inverse gate is a bar. That means A bar. That means it will alter whatever input we will give, only it will alter it. So according to Boolean algebra, the input have two choices. One is 0 and 1. So if the input is 0, then it will alter it, means the output will be 1. And if the input is 1, then the output will be 0. So these are the two conditions that we have. So let us draw the circuit diagram for it. And see that how we will get this type of output. So for this, what you have to take, you have to first take a switch over here. So let us just take a switch. In parallel, we have to attach a LED through a resistor. What is the use of this resistor? That resistor is going to just protect the LED from damaging condition. So now the entire circuit is now parallelly connected with the battery. So this is the positive terminal of the battery, this is the negative terminal of the battery. So it is connected in such a manner that the positive terminal will be connected to the P side of this LED such that it will be forward biased. So this is P side, this is N side. So now the LED is forward biased. Now let us just take that this switch is my one of the input. We can assume that this point is A. Now if the switch is open, that means 0. So the upper branch is disconnected, this branch is disconnected, means the LED is going to glow because the current is going to flow in the lower branch of the circuit. Now what happens? If the second condition, the upper one is connected, that means the upper part is closed. If the upper part is closed, what is happening? You see, if the upper part is closed, the current always flows in less resistive path. If the current flows in less resistive path, the current is going to flow here in this upper part and it will not move in this lower portion. That means the LED is not going to glow. We are going to get the 0 as the output, or the lighting condition we will never get in this type of arrangement. So let us do the circuit arrangement and demonstrate how it works. According to the circuit diagram, I have just arranged this circuit for demonstration. You see, this is my switch where it is written 0 and 1. That means 0 is off, 1 is on. So the switch is parallelly connected with the resistor and the LED. You see, I have connected that parallelly with the resistor and the LED. Then this two end, you can see in the diagram, this two end are connected to the battery. So this two end are connected. I will connect it to the battery. So let's just connect it. Okay, just try to understand. So what is the circuit you see here? This switch is off, that means 0 is pressed. The switch is off, that means the upper branch of the circuit is open. So current is flowing in which branch? The lower branch, and we are going to get the glow of the LED. So the LED is glowing. So we have the output which is high. Then the next condition, if the switch is closed, now just switch it on. Now you see what happens. The LED is not glowing. Now the LED is off. Let me do it fast so that you can understand. If this is off, that means the switch is off, the LED is glowing. That means if it is 0, input is 0, the output is high. And if the path is connected, the upper branch is connected, then the current is flowing across here and the LED is not glowing. So this is the experimental verification of the NOT gate. I hope so all of you have enjoyed. Thank you everyone. Thank you for watching.